Fine. So now that we know the life cycle and the tools, right? So which means tools under access layer and discover layer, informatica analyst, informatica develop, data explorer, and then cleanse, informatica developer, MDM, informatica MDM, integration power center, delivery interface. We need to build our own interface, and target will be Teradata, Amazon Redshift, or whatever. Yeah. So that's about what you call tools that we use within this life cycle. Yeah. Now let us start getting into what I call next step, which is going to be what data quality specific. Because from this we know where data quality comes in, right? These two layers, one discover layer and second cleanse layer. So both of them we are going to focus as part of this particular program, right? So now we need to talk about data quality specifics. Yeah. So this is a diagram, guys. Like whatever we discuss in Notepad, that same thing can be seen here. Access, discover, cleanse, MDM is missing here, integrate, deliver, and target, right? So in between we can say tools, right? So I think this we discussed. Yeah. So now remember, if you look at this top portion, right? So we can use this particular life cycle to take care of what building data warehouse. We can also use this life cycle to perform what data migration also, like migration of data from mainframe system to database or mainframe system to an application or database to an application or whatever. Yeah, one to another. Yeah, and data consolidation. Remember, guys, if you get data from multiple sources and we need to take out unwanted data and maintain only wanted data. In that case, we identify where there is a unwanted data, we take it out and create a good copy, which we call data consolidation. You can see in this diagram, right? There are three, one has been taken out, and from two, we have got single copy. That's it. Mass data management is also same thing, guys. If we get data from multiple source systems and we maintain a single copy, which we call a master data. And data synchronization. Remember, guys, let us say we got quality and we got Salesforce. Now we need to make sure that whatever data that we have in quality side, same thing should exist in Salesforce. How do you make sure that? That's where synchronization. So we can build data synchronization task to take care of what these two applications are in sync. In a sense, whatever data exists in data quality should also be part of Salesforce. Yeah. And data exchange, guys, and data transformation. Remember, if you want to or take care of one business to other business, we can use this B2B data exchange. Not only that, if you want to convert one form of data to other form of data, like unstructured to structured, whatever, right? We can also do it. We can also use that. Yeah. So we can think of several things. Only some of them have been listed here. We can think beyond this. But for now, you can just remember whatever is there as part of this particular slide, so that I'm going to share this slide. You can have a look at this. Yeah. Yeah. Now we are going to focus on what data quality products. Yeah. So one is analysis part. Second is what cleansing part. Yeah. So cleansing part, we can also call it as what quality. Yeah. So where we qualify the data, like to come closer to the 100% of accuracy, if not 100%. Yeah. Cleanse, quality, correction, they're all synonyms. Don't confuse. Yeah. And what do you correct it? Data. And this corrected data would be stored in the warehouse, which will be converted to what? Information. Yeah. That is the later part of the story. Yeah. Yeah. Now let us talk about left side, which is Informatica Data Explorer or Analyst. Yeah. So main goal of this particular, what you call left side, is what? To take care of analysis part, which is in the sense identify the issues from the source system data. Like issues could be expressed at column level, set of columns level, or dependency level, or link level, or key level, whatever. Issue could be of any sort. Yeah. But as a solution provider, we need to know like how to what you call identify those issues. Right? Yeah. Now let us try to talk about some of the bullet points that we have under this particular uh, explorer part and also quality part, right? So now the first thing, rapid analysis can be carried out based on multiple source systems. Remember guys, as I said earlier, we can carry out analysis one with a manual approach, second with what automated approach, yeah, which is the best farmer or later because the tool or automated way, right, which always gives what I call better accuracy over manual. So we're all humans, right? There's a chance to make mistakes. So those mistakes can be avoided by using what pre-built tools. One such pre-built tool is what Informatica Analyst or Informatica Data Explorer. That is why we can use the term rapid analysis. Manual means one, we cannot carry out in a rapid way, and second, there is chance to make a mistake. So both of them will be solved by using what? A tool. Example, Data Explorer Analyst. Now, once you carry out analysis, right, we need to store it somewhere because during later point in time, we need to see what was figured out and we can avoid those mistakes in the coming or for the forthcoming data, right? So cataloging part. Not only that, this particular cataloging of metadata, right, will be stored in one of the central repository that can be taken as input to what some other tools. There is a separate tool called EDC, which is Enterprise Data Catalog, and the job of this particular EDC would be what? To carry out analysis for what? Metadata. Yeah. In that perspective also, it is always advisable to catalog of what was done. Yeah. Now, what do we do it as part of this particular analysis? One, we pull the data from the table or a file or some other application, and in that we take one or more columns and see what went wrong. And we can also have corresponding domains identified. So, which means like SSN data, PAN data, other data, whatever, right? They are domain specific, what you call data. In the sense, identify source media, identify corresponding columns, then corresponding domains, and start identifying the issues and that try to what you call capture these meta details, like what was identified as an issue, right, as part of repository. Yeah. So now the next bullet point is what data structures. Remember, guys, in data quality, or sorry, in analysis layer, we got two types of data. One data structures, I can say. One is what? Documented data type. In short, we call it as DDT. And other is what? IDT, which is info data type. So DDT, we can also call it as source data type. Yeah. So IDT, we can also call it as actual data type. Yeah. Remember this, which is this is a projected one, this is an actual one. In a sense, let us say there is some source data. When you try to create the definition, and this particular definition would be created based on source data for each column. Whichever record has got longer in length, based on that, this particular type will be created. Type would include built-in type with along with the length. Remember, so that would be taken care as part of what DDT or SDT. And other one is what? Inferred. Remember, guys, inferred is the one that will be taken care by the tool, which is analyst tool or explorer tool, where we take care of converting, or do we need to use document data type as a base? If not, convert that to what? Actual data type or info data type. That would be taken as a base to carry out what? Analysis. Not only that, metadata issues will be identified by using what? These two, DDT and IDT. Yeah. So that's one of the factor for metadata, right? Now that's about data structure, guys. In simple terms, we can say that data structure is part of what? Metadata analysis. Yeah. And first two things are for, let's say, three are for data, and fourth one is for metadata. Now in data quality, we have got multiple measures, yeah, or dimensional measures we call. Dimension means, let's say, subject area. If you take a customer, subject area, or a product, subject area, or let's say vendor, subject area, what are the measures that we need to keep in mind in order to say that our data is what? As closer to the 100% of accuracy as possible. Remember that. Yeah. So those things, I'll talk about it. For now, you can just remember like whatever you have here. Data completeness is going to help us whether the input data is complete or not. Yeah. So meaning, let us say we got uh, date, and data has got null. We expect some valid. In that case, incomplete. Yeah. We expect validated value, but we have got a null. In such case, data is incomplete, right? Similarly, we expect 10 characters, but I got only one character. In that case, also data is incomplete. So likewise, we can think of many examples where data completeness would come in. Clear? Now, redundancy, as we all know that in case if there are any duplicate records, by using what? Explorer or analyst, we can identify like how many records where there is a duplicacy. That's it. Only identify here. You don't fix it here. We can only identify and leave it to the downstream layer to get it fixed. Yeah. And now the next step is what we have: high level IDQ issues and statuses. Remember, guys, we can only identify high level DQ because the scope is what here discovery part. DQ we don't focus, right? DQ part will be focused on the another box that will be discussed. Yeah. For example, we talked about duplicates. So here also we can identify duplicates, but high level here detailed part can be done. Just remember one example, which means what? Detailed way of identification of duplicacy would be done as part of IDQ. Whereas in discovery layer or explorer layer, we can identify high level data quality issues. Clear? Now, once you identify, right, so we need to tag it. Yeah? So for every data where we identified issues, and we can also document it so that this will be taken as a base for further what you call actions or further decisions or whatever. Yeah. So that's it about Explorer features. But we have got some more things like a scorecarding, reference table, and we got exception management. We got human task operations. We got mapping specification. We got what do you call some more what do you call Explorer operation. That anyway we are going to see once you get into what hands-on stuff. Yeah. So that's it, guys, about analyst features at high level. Yeah. So if anybody has got any questions, yeah, so please let me know, guys, about left side, which is Explorer part only we focus so far, right?
No problem.
Okay, fine. Now let's move on to what next part, which is IDQ. Yeah. Remember, guys, if you say our data is what quality data, it should be quality data based on what some pre-built rule sets or rules. Rules means what? A rule is what? A logic. Logic is based on what? Mathematical expression. For example, quadratic formula b square minus 4ac by 2a square root of we all know that, right? If the input data is not in line with what we expect as a result of this particular quadratic expression, then we can say that data is inaccurate. Yeah. For example, for today's business, we expect what data which is more than 40 years of age, let's say 90 percentage, but we got less than that. So data is inaccurate. Yeah. We expect something, but we got something else. Then we can say that the difference is going to be the inaccurate part, right? That's a simple way to understand quality. Or we can say it's a difference between a predicted value or predicated value against with what actual value. This is the definition as per the metrology, right? So that's it. Now let us see, where do we build these rules or rule sets? Rule set means what? More than one rule. So it's not mandatory that we build only one rule to what we call detect quality data. Yeah, we can have one or more than one. In that case, we use a term which is what? A set, which is a rule set. Yeah. So that's it, guys. And then we have first thing, analysis part, that we have taken care as part of this. But we can also build set of rules, carry out analysis. For example, if you take a banking industry, right? Let's say investment banking, where they focus on what? Exposure calculation, which means what? Prediction of which are demands, or prediction of which are exposures. For that, we have got pre-built formulas to calculate that exposure. Now, we apply what I call a rule to form that particular exposure statistical equation. Now, we carry out analysis, which is going to be the result of that particular exposure. So that is part of analysis. Remember, which means what? It is not mandatory that whatever data comes out as a result of source system data should be taken as a base to carry out analysis. But we can also have derived analysis. Derived means what? We can build a logic, and this particular logic would be based on what? Source system data. Then we carry out analysis based on the result of this particular logic. That's where we call it as what we call rule based analysis. Yeah. Yeah. Now, the next is what, remember, guys, as part of quality, main focus point would be on what? Correction. Like I was trying to give one example over here when I talked about this life cycle. Let us say if the data has been represented in different forms, we expect one, but it is not. It is more than one. Now, how do we convert n number of representations to a single or unique representation? So that would be taken care by using what? Standardization. Now the question, what are the different ways through which we can perform standardization? To answer that, we got two broader options, manual and with a reference table. For now, you can just remember this, but we are going to do it with the practical examples and see the essence of this particular standardization. Yeah. So with reference table, what do we get it? Without reference table, what do we get it? And which is the best suited for building more or less closer to 100% of accurate solution, right? And remember, enrichment in the science, remember, guys, whatever data that we get it from the source, it's not mandatory that it's 100% of good data. We perform either or we apply either suffix or a prefix to a source system data. So that's what we call data enrichment. So enrich the data of what we get it from one or more source systems is what called data enrichment. Yeah. For example, we just have got a name. So we can have prefix of Mr. or Doctor, whatever, right? That's a simple example of having a prefix to the source system data. Clear? And now next is what matching is a very big topic, guys. We are going to spend a lot of time on that, where what are the ways through which one can identify the duplicate records? And once you identify duplicate records, how are we going to convert n number of duplicate records to a single record? So that's going to be the consolidation part. These both of them would go hand in hand in order to build what I call quality data. So, but anyway, so in match, we got a lot of what I call rules, which could be based on the identity match, or it could be based on what I call field level match, or it could be based on a clustered match, could be based on match page, whatever. There are lots of what I call matching techniques that we can apply to identify what I call matching records. Especially in the cases where we have let's say mergers, right? As we all know that big fishes will eat small fishes, right? So similarly, so big companies will buy small companies. In that case, if they are in similar lines of businesses, then you can see what matching records. In that case, how are we going to start identifying? One, matches. Second, avoiding them. So that's where duplication, deduplication, both of them would be carried out as part of this particular matching and consolidation. Clear, guys? So that's it. Like how match and merge or match and consolidation would take place. Yeah. Now, once we identify or once you create a good record, now do we have any way to get it monitored? Answer is yes. We got central monitoring mechanism of what we do and where do we do it and how do we do it. That anyway we're going to see with the hands-on sessions, right? And now let us say how do you make sure that whatever data that we produced is in par with the business. So we need to generate a report, yeah, and say since last 6 months or 1 year or 5 years, where we stand with respect to what data quality progress. In the sense, what was the quality year back, what was the quality 6 months back, and what is the quality in today's business. So those three things will be solved by what is the generating a report and see where we are or where we stand with respect to what quality progress. Like for example, let's say 1 year back, 70% of quality, 6 months back, 80% of quality. For now, let's say 90%. This is how the progress should be. But it's not mandatory that we have this only always in an incremental order. It could be even other way also because of many factors. What are those factors and how to identify, how to get it fixed? That is going to be the big challenging part. Anyway, we are going to talk about it. What kind of challenges that we face and how to get it fixed by making use of this particular quality, right? That is fine. We have built n number of quality tools in order to perform these operations, like whatever has been discussed so far. And now we can deploy them, and we need to make sure that managing part, yeah, which means we need to start getting them modified as and when the changes occurs and keep on redeploying and start getting it managed over time. Time could be 3 months, 6 months, 1 year, whatever, right? Yeah, this is what I was trying to talk about earlier. Remember, guys, anything and everything can be done by using quality. There are some rich points in quality. There are some rich points in Power Center. There are some rich points in MDM. So we need to what you call make use of those richnesses of each of those tools and start building what you call a good solution. Right? That is why In this particular what you call bullet point, the main focus is what Power Center has got some rich features, especially monitoring part, high availability part, and some more integration things, right? Which we can't get it or which we can't do it by using what quality. So that part we can just integrate and start availing the rich features of what we have within the Power Center, right? And the next step, guys, this deployment, right? Depending upon the expectation, we can decide whether to go with what batch deployment and real-time deployment. I think I talked about the modes of execution earlier, right? Similarly, modes of deployment also. Yeah. So if the need is what real time, then we need to go with what real time deployment. If let us say as and when we need, we just expect something from quality, then we go with what batch deployment. So depending upon what downstream application or downstream tool expects, right? We need to take a decision to go with what proportionate deployment strategy. Batch means what? Whenever they're needed. Real time is what? As and when or as and when the data comes in. So based on this, we need to take a call. Yeah. Clear, guys? So now in the top portion, we could able to see life cycle. And now we with that we know where this quality comes in, right? Discover and cleanse. And both of them have been discussed over here at high level only. Yeah, very high level features. There are many detailed features that anyway we are going to talk as we go on, right? Yeah. Now there is a next level of detailing about discover layer. That's what we can see as part of this particular slide, right? So remember, so we talked about one of the major point in discover layer is what profiling or understand. So in analysis layer or analyst tool or explorer tool, it supports multiple profiling techniques. Can you see here, guys? So column profiling, function dependency profiling, cross table analysis, or orphans, like using join, you can identify. You can also tag and mapping specification can be done and have maintain the repository and generate a report based on the what you call based on the repository and see what went wrong with respect to what metadata. Yeah. So there are some more things which are not listed here, like rule-based profiling, which is not listed. Yeah. In the sense, so we can have what is a derived column based on what source columns, and derived column would be taken as a base in order to carry out the profiling. Remember, guys, as part of column profiling, each and every column would be analyzed with respect to what different pre-built properties like nulls or not nulls, range, metadata, dupes or no dupes, patterns, statistics, all that. They're all the examples of properties that will be taken as a base to see like what you call how much or how many issues that we have with respect to what each and every column. But remember, guys, in reality, right, though we have 20 columns from the source systems, it doesn't mean that we need to carry out analysis for all the 20 columns. So out of them, we need to filter out key business columns and focus on those key business columns in order to carry out analysis. So we can say that we focus on business data driven columns as part of profiling, if not all the columns. But if the customer expects all the columns to be profiled, then we can go with it. But in rare cases, it would happen. But most of the cases, we would go with what? Key business data driven columns. Yeah. So, and dependency, guys, dependency means, let us say, one column would be functionally equivalent with what one or more other columns. For example, if you take any country, right, there is a zip code, right? So how the zip code formation would take place, guys? there is a zip code. So zip code formation would take place one based in the province and city, or based in the state and city, right? We all know that. So state plus city, simple way, right? So zip code, right? For example, if you take 60036, which is what yeah, which is what Chennai, sorry, Tamil Nadu is a state, yeah, and then city Chennai, right? So which means these two would be taken as a base to form what a zip code. That's it. It's as simple as that. Which means zip code is functionally dependent on state and city. This is a simple example to understand how this particular functional dependency analysis is going to work. Clear, guys, to everyone? Yeah. So we are going to do it practically probably after lunch. So now make sure that these foundational topics are very clear. Yeah. So yes. Now redundancy profiling. Remember, guys, see, so far what we discussed was if the data exists in one data object or one medium, like a file or a table. You know? Now the question, let's if there's a data which is spread across multiple tables, you know, and one table data might have dependency with other table data in terms of duplicacies, in terms of keys, or in terms of something else. Yeah. In such cases, we go with what? Carrying out cross table analysis. Cross table means more than one table. Let's say department table, employee table, right? Or let us say vendor table and supply table, or customer table with what do you call customer category table. So likewise, we can think of several examples where we can carry out cross table analysis. Yeah. So in that, we can identify key-based issues by using foreign key analysis, and we can also identify orphans or zombies or any other matching ones by using what? Join key analysis. So which means what? A join key analysis, foreign key analysis, they're subset of cross table analysis. Just remember that. Yeah? Cross table analysis is a broader term, and specific analysis techniques are what? Join and foreign key. Yeah. So that's it, guys, about broader level profiling techniques. But now, once you carry out analysis or once you carry out profiling, right? So we need to tagline it and provide proper documentation so that this particular tags would form as a basis point to take further actions, yeah, in near future. So that's it, guys, about high level explorer features and analyst features. Yeah, can you see in this particular screenshot? So here column and distinct records, nulls or whatever, right? This how we carry out what? Column profiling. You know? And we can also see charts or whatever, you know, or we can also call it a scorecard. That we'll see later. Yes, ultimately here we use this particular explorer to take care of identifying the issues. So issues will be part of analysis. Yeah. So that's it about major features under analyst or explorer. Yeah. Yeah. So I said these things will be discussed later, right? Now the time has come in to understand what I call data quality dimensional measures. Remember. So these things we should never forget. Remember, because without this, there's no quality solution. So we need to make sure that all of these six dimensional measures have been taken care while building a quality solution, right? So now let us start understanding one after another. Yeah. The first one, completeness. I'll try to give one or two examples for each. Yeah, completeness, for example, as I said earlier, let's say we have got date. We expect what? Not null. And we got null data. Then we can say that data is what? Incomplete. Yeah, that's one example. Second is what? We expect date in what? DD, MM, and Y. But we got only Y. In this case also, data is what? Incomplete. Yeah. So, and zip code. So we expect, let us say in India, we expect what? 6-digit zip code. But let us say we got only state name. In that case, it is what? It is data is incomplete, right? Now, that's a one way to define incomplete or completeness measure. Next is what? Usable and unusable. In the sense, let us say we have a data, but you are not using it, which means what's the pointless, right? In the sense, whatever data that we have, see whether it has been used or not. Yeah. For example, there is a column called address, which is not used at all. In that case also, data is what? Incomplete. Yeah. So which means we identify this particular completeness measure with the two possible ways. One, unusable, unused, and second, incomplete. That's it about completeness measure. Clear, guys? I think I talked about it with simple examples so that everyone can understand this, right? Any questions, guys, so far? Vishwan, Jesudas, Nitwala, all.
No, not.
Okay, fine. Now let us talk about conformity. You know, so conformity, as the name suggests, format. You know, so yeah, let us say, I think we talked about here, right? We expect data in this particular DD, MM, YYY, but we got MM, DD, YYY. So in this case, non-conformed. In simple terms, we use NC, you know, non-conformity. Clear? Simple example, right? So which means we expect something, but we got something else. In that case, non-conformity. For example, so business expect 99.99% accuracy, but we got only 90% accuracy. So which means there's a non-conformity. This is from accuracy point of view, right? And another one. Let's say we expect a deviation of only 0.9, but we got, let us say, 0.99. So there is a, what do you call, mismatch in expectation. In that case, non-conformity. Yeah. Not only that, zip code we expect 6 digits. Yeah. So but we got only 4 digits. In that case also, it's a non-conformity. Right? Yes or no? So likewise, you can extend this to many more examples, right? Yeah. Consistency. Yeah. So let me talk about it with one example. Yeah. So yeah, let us say there's a source data, yeah, which contains, let's say, state. Chennai. Let us say I'll put zip code 60036. And state is, let us say, Tamil Nadu, and city, let's say, Chennai. Yeah. Now, likewise, we got n number of rows. For the same zip code, another entry 60036. Yeah. And data is from Tamil Nadu, but state is, let's say, Madurai. In this case, data is what? Inconsistent. Same zip code is pointing to what? Multiple cities. That should never happen. So in such cases, we need to resolve this particular inconsistency by taking the help from business analysts. Business analysts, they would come up with what? A base table, which we call a reference table, because the business works based on the reference table. Now, our solution also should be based on what? Reference table. Whatever reference table says, we have to build solution which is in line with that. Yeah. So that's what we need to do it to fix it. Yeah. One simple example with respect to what consistency. Yeah. So not only that, so we talked about format data, right? Let's say data format 1, 2, 3, and other records are following what we call 7, 8, 9. In the sense, we expect data with a comma delimited data, but we got what? Some comma delimited, some colon delimited, some semicolon delimited, some pipe delimited, and so on, which is not expected, but we got it. So such in such cases also, data is what? Not consistent. But that's not a good example. The good example would be this. Yeah? That is basically from syntactical perspective. This is purely from data perspective. Yeah? Because we should always think from what? Data in order to identify issues. Not, we can also think from syntax and semantics with respect to meta also, but primary focus point should be purely on what? Data. No, clear, guys? So everyone, yeah. So now the next point is what? Accuracy. Can you see here? Which is incorrect, which is out of date. Yeah. See, as per the methodology, right, we define accuracy based on what? Predicated value against with actual value. For example, we expect 99.9 accuracy, but we got 99. And what is the percentage of what you call variation here? Let's say 0.09, whatever. So that is what we call accuracy. Yeah. So especially we use this accuracy quite a lot, especially in what? Manufacturing industry, pharma industry, any industry you can take, especially when you deal with what? Mission critical applications like aerospace industry or financial industry. That's where what you call they expect more accuracy because they're all mission critical applications. Yes or no? In such cases, we should what you call spend more time to identify what you call very closer to expected accuracy. If not, so we need to identify the causes of not reaching this particular expected accuracy. Yeah. Yes. So that's where accuracy comes in. And duplicacy, we all know, right? So, for example, for one customer data, let's say there are two entries. Because after merger, right, you'll have two entries, or after acquisition, after buyouts, whatever, right? So let's say one company bought over by somebody else, some other company. In that case, there'll be duplicates. Now the question, what are the attributes that need to be considered in order to identify the duplicate records? Or are we going to consider all the attributes or subset of it? That's a question. But most of the cases, we consider what a subset because most of the columns or some of the columns will not be used much. That's why business would focus on what key columns, key not constraint based key columns, which means business important columns. So those columns or business columns should be taken as a base to identify what is the percentage of duplicacy or what are the records where there is a duplicacy. Thereafter, we need to start applying corrective techniques to convert duplicate records to a single record, which we call a master record or quality record. Clear, guys? So duplicacy is going to be one of the key challenging topic as part of this quality, guys, because we need to put in a lot of effort to identify like percentage of duplicates because we never know. In one industry, they expect what 70% of accuracy. Some other industry, they expect 90. Accordingly, we need to what I call build a solution to arrive to a right numbers. Yeah. Yeah. Now the next measure is going to be integrity. Integrity is purely driven from keys, which is constraints, right? Let's say this particular measure is basically applicable if you have data which is kept in more than one table. But in reality, or most of the projects or products, we use what? Multiple tables. So which means we identify good or bad based on one table which is referenced from other table. For example, we use a term, a reference table, or a lookup table, or a base table, or a business table. That's where business data would be defined. Now, why do we need that? We need that to compare this business data against with source data. For example, we get the data from what I call multiple states within India, like state 1, state 2, state 3, state 4. But those what I call states records should be or should follow with whatever central government has defined. In this case, central government data is going to be the business data and state data is going to be the source data. So which means if there are any issues with respect to state sources data, we need to get it fixed by comparing with reference data that we have or that we got it from central government. Simple example to understand where exactly this particular integrity measure will be used for, right? So that's it. So likewise, we can think of many examples. For example, let us say we got a customer data, yeah, and customer data should be driven based on what? Let's say if the bank means what? Bank reference data. If it is credit risk, customers means credit risk data, and so on. Which means for any business, if you take any business, right, there is going to be what I call base data. Based on that, business would operate. And based on that business data, we have to build a solution. This is how the sequence goes. That is why integrity is also one of the measure in order to identify whether we have got quality data or not. Yeah. So that's all about the measures supported by data quality. Any questions from anybody, guys? So these measures should be keep in mind in order to build a quality solution. Remember, in a sense, uh, we need to make sure that did we take care all of those measures or not while building a solution. If not, we have to take care of it. Yeah. Yeah. Any clarification needed, guys, on these measures? Yogesh, Sampas, Sri Manga, Soundarya, all.
No.
Okay. Mm. Now we can see some example. Can you see here? This is sample data for customer, you know, where you can see account number, name, street, address, state, city, whatever, right? We can see here. Yeah. And some column where there is no data, unused columns. So we have seen, right? If it is unused, also it's part of what incomplete. So completeness measure has been should be applied here. So make sure that we got data for all the columns. Example, understand. So now completeness we have talked about it, and conformity. Conformity in this sample data we can see. Let's say account number. We expect 10 digits. If you have 8 digits for some records, right? Then it is not confirmed. And consistency. Yeah, consistency part, whether we have that data here or not, I don't know. Let's see. Mm, it's not visible properly. Yeah. See here, for this, there is no data. For this, there is a data. So it's not consistent. For same thing, there is a data. For others, there is no data. Inconsistent. Yeah. Duplication part, I think there will be many records. Yeah. The duplication, right? See, all the records have got similar name. Integrity, multiple tables, but here integrity, remember guys, as part of integrity, it is not mandated that this constraint or referencing should happen across a number of tables, but it could also happen within itself, meaning intra-table relationship. For example, if you take any company where you'll have n number of employees, like team members and team leads would report to what? Manager, right? In that case, intra-table relationship, there is going to be a single table, which we call employee table, within which we could able to see the relationships among a number of different types of employees. That's where integrity measure would come in, right? And so here also we can see intra-table relationship, like for example, account name. See, account holder, one might play a role of manager, other account holder might play a role of what? Junior employee. Yeah. This junior guy would report to manager. So in such cases, we can have intra-table relationship, right? So accuracy, I think we talked about, right? It's a difference between the prediction and actual. Yeah. Yeah. Now let us see here with some examples, some more examples. So conformity, yeah, data is not confirmed. We expect something format which is not there. Consistency, see here is one thing and here is something else. Accuracy, here we expect something, we got something else. Completeness, complete code is not available. We expect complete code. That's it. We can think of several examples. I've already given some examples. But anyway, we are going to see practically by using a tool to understand all of those measures one after another. Right? So we can build many scenarios to understand all of those measures and see how are we going to what you call start applying corrective techniques in order to build foolproof quality solution, right? Now, the next question, as we all know that in data quality, or in order to arrive good quality data, we need to do what? There will be multiple stakeholders who would be part of this particular company. For example, developers, they would start applying cleansing rules or building cleanse logic and data stewards where they would start identifying or performing reviewal process to identify where there is any duplicacy or where there is any bad data, where there is any erroneous records. So data stewards, and third manager where they can take a call whether to approve or reject or cancel or escalate or reassign. Such kinds of actions would be taken care by using what manager role, right? And then we can also have what is SMEs, subject matter experts, where let us say they have got deeper knowledge in one subject area. They would be contributed to identify whether there is any data issue in that particular subject area or not. So this way, there is going to be multiple stakeholders in order to build a quality data. So in such cases, we use what? A collaboration, in the sense multiple stakeholders need to interact with each other in order to build a quality solution, which means what? The output of this particular developer, that would be taken as input to whom? As a data steward, where they would take a call like what is good or what is bad. And based on that, then they would start applying the correction. Then this corrected data would be sent to another stakeholder who is going to be what? Manager, where they would take a call whether to accept or reject or escalate to what? Senior data steward, where they would take a look at again the corrected data and get it reprocessed. Yeah. So likewise, every issued record would undergo several levels of approval process. At the end, they would take a call whether we can consider this record as what? Good or bad. Remember that. Yeah. So that's it. So that's where collaboration part would come in. And reviewal part is done. And we also have got a drill down feature, guys, in the sense, let us say we got organization, right? MD, CEO, vice president, associate vice president, and so on. Now the question, we got complete data, but out of that, we need to pull only what? Team member data. How do you get it? We need to drill down from MD to lowermost part of this particular organization, which is what? Team members. Remember, so in such cases, we use what? Drill down. Not only that, let us say we identified 10% of source data has got what? Anonymous data or duplicate data. Now the question, what are those records where there is a duplicacy? To identify that also, we use a concept of what? Drill down. Yeah. So likewise, we can think of many other scenarios where there is a need to start thinking of using what? Drill down feature. Clear, guys? Especially if you take another example, let us say we need to calculate sum of salary drawn in one of the department out of n number of department. In such cases, we need to drill down from n number of available departments to what? Expected department, and start applying what we call appropriate aggregation, which is to calculate sum of salary drawn in a specified department. Yeah. So that's one more example where drill down feature will be used for, right? So that's it. Yeah. So with this, I think we can take a break for lunch. Before that, we can have question answers, right? So after lunch, right, we'll start getting into hands-on, like whatever theory we discussed, right? We'll try to do it practically one by one so that you will understand much better. Yeah. Yeah, these are the theoretical points. And what are the plus points and minus points or strengths and weaknesses of this particular quality would be discussed as we go on. It is too early to get into this far at this particular stage. I'll talk about this particular slide after understanding some of the quality features at high level with practical examples. Yeah. Okay. Yeah, I'll try to share this particular presentation. Probably after around 5 o'clock or 5:30, right? You guys can just give me mail ID so that I'll just share this presentation along with the material so that you can just go through before you come for the next day. Yeah? So can you see here? So this is one of the good uh, presentation where you can see very detailing about like uh, how to identify quality issues, how to fix, and what are the different techniques that we can adopt so that we can come up with uh, precise solution. Yeah. So yes, yeah, I'll talk about these things again. Probably, I think I'll talk about this architecture of data quality. Yeah, before we get into hands-on, then we'll go with like how to get into the tool and where to start to come up with what quality techniques. Yeah, because we need to understand the starting point and the role. Are we going to be part of this particular building a solution? We, in the sense, developers, or somebody else, like admins, stewards, SMEs, or somebody else, right? So these are the questions. Yeah. I'm going to answer those questions. Yeah. So, like a way to start, and which is a crucial role where the kickoff would take place. After that, we can start getting into the usage of other rules. Yeah. Yeah. So with this, probably we'll take a break for lunch, guys. So we'll meet around 2 o'clock. But prior to that, if there are any questions, you guys can shoot out. No. So with this, probably we'll take a break for lunch. So we'll meet around 2 o'clock, guys. Yeah.